Hello guys, welcome back. So in my last video, I left the whole modeling thing at this point where I built the whole geometry. So now I will move forward. So after this, we need to build the whole simulation thing, like setting up the whole simulation that will involve four different modules here. And to do that, we can just select this like add physics, and then you will get this tab here. So since we are going to do thermal analysis, the first thing we need is the heat transfer thing. So this is like heat transfer, and the heat transfer would be like in this domain here. In fact, it will cover the whole thing. So for that, I think we need heat transfer in fluids, maybe. Yeah, probably that. Okay, here it is. So in the fluid part, you see we have like all of them selected, like default wise. This covers the whole thing, but since we know that these solid parts are not exactly fluid, so for that we will be needing like these domains here, solids, to refer to individual batteries. Now in my last video I developed these, right? So I also explained why I'm creating these extra selections here to specify individual parts of this geometry. So this is where that comes in. So basically when I turn this, like open this up, I can see that battery 1, battery 2, all of those selections, right? So the solid one would representing battery 1 here, right? Like this. And additionally we will be needing another solid for battery 2. Just select battery 2 from here, and then another solid like this, and then select battery 3 here, and finally one more solid, but this time instead of like batteries, we will be connecting, like selecting those as connectors because they are also solids. So that's for those. Yeah, that's one thing. Now before I go any further, I need to specify quite a few stuff here. Also make sure that this T here, it's T, because default wise it's T. You can change it. Just to, this is like what you are solving this whole module for. That's temperature, right? So that's that. And before that, we need to define some extra variables like the parameters, like what will be the thermal conductivity and stuff. For that, we have before we define these geometrical parameters, we need to define extra parameters for material properties and stuff, or maybe other variables that we are going to use in the simulation. For that, you can create an extra variable, and let's name it as like battery parameters, maybe something like this. And yeah, so for what parameter those are, I will like copy them from the simulation that I already developed. So these are like geometry parameters which we already have, and these will be what we are going to copy from here to our model here, right? So the question is, what are these parameters? So C rate. Now when you deal with batteries, you come across this variable C rate. This basically specifies how fast or how slow you want your battery to charge. 4 means like you want it to charge 4 times faster than its normal condition is. Then the next question would be, what exactly is the normal condition here? So that normally also like when a manufacturer normally provides you with this one, like they have this value called ampere h, or basically the battery capacity. So they simply just divide it by 1 hour, and that would be like for your current value, 4 ampere. Now this means that in 1 hour, if you apply 4 amperes current to a battery for 1 hour, it will charge to its 100% capacity, right? So this 4 would mean that instead of 1 hour, I want it to charge 4 times faster. In other words, instead of like 1 hour, that is 60 minutes, I want it to charge in 15 minutes, right? So that's what this for C rating means. Q cell indicates the simply just the like the maximum capacity the battery have in term of coulomb charges, and this is what the applied current looks like. We will simply multiply this current with C to basically define the faster charging. This K is basically thermal conductivity. These are like angular. These are two, just this is just a coordinate thing in angular direction and in radial direction, the heat or thermal conductivity. And EA refers to activation energy. Now there are three different activation energies. These refer to three different phenomena that normally occurs in a battery. I will further discuss them when like I will use them in the simulation. And for example, this one, and these three are activation energies. T naught is like the reference temperature. Similarly, the reference value for this EA, J, O, J naught, this is basically a dimensionless number here, this J naught. And what it deals with is basically a transfer current, or you can actually study that on your own on internet. Tau is basically tortuosity reference value, and what that is, we will just further discuss that in where I'm going to use that. Similarly, eta IC corresponds to this value. So these 6 different values, they are like correspond, these like pair, and in other words, they refer to 3 different phenomena. Raw battery, the density of the battery, the specific heat of the battery, heat transfer, HT, heat transfer coefficient, that we will apply at the boundaries. T initial is like the initial, and as well as the external temperature that we will consider here. So these are like extra parameters that we need. Now, other than that, we need to define few stuff. Like first thing would be analytic. Now, analytic is basically we're trying to develop a function so that we don't have to write the whole equation every single time. So that's what analytic does. And what that function is, it would be simply Arrhenius equation. And the expression for that, let me just copy that instead of like writing it again. So this is like our Arrhenius expression, and the arguments, which is EA, and this temperature here, we need to specify that as well. So this would be our expression here, and the arguments would be this activation energy and our temperature here. T node is the like the reference temperature, the initial temperature, so we don't need that. So here we go. So these two are the arguments, and other than that, we need like, let's keep this as 1, but the thing is we need to define specify the units of the arguments. Like EA is activation energy, that would be joules per mole, and temperature is simply in kelvins here. So that's one function. So now every time we have to utilize this equation, we will be using this function name with bracket and then the arguments, 2 arguments, which is activation energy and temperature. And other than that, we need few stuff, because if you are even slightly familiar with batteries, you will realize that we normally add the 2 extra parameters. One is like the voltage difference, which is open circuit voltage to be precise. So we will define that as a variable. That's sorry, not exactly variable. We need interpolation, because normally you have experimental data here, which is the case here as well. So I will be using interpolation data. So instead of like local table, I will have a file, which is a text file, and I will make sure to put this in the description down below, so you can download that one, these 2 extra files that will that I'm going to use here. One is like this E, which is potential, and OCP means open circuit potential. So simply just text file, I'm opening it here, and what it looks like, what the function is, you can simply just use this plot here. So this is how like our open circuit potential looks like. Now the question is like, what are the units, right? So the units, this is basically in volts, and the function would be in volts, and the arguments, we can keep it as 1. And just to double check this, like if I'm doing this right. Yeah, that's fine. Just think 1. Yeah, it looks good. Okay. So we can name this as like, let's say, electric open circuit potential. Yeah, so this will be for that, but we need another interpolation, which is here, and this one will be for, now notice what I write here, so that will be dE divided by dt, dt. So this is like when you change the temperature of this, like when as the temperature change as well, that change in temperature will affect your voltage or potential difference as well. So how that change will occur, for that we need like experimental data as well. I have another file for that, and in this case the function would be we're dealing with how the voltage will change with respect to temperature, that would be Kelvin. And to see how that works, we can simply plot this one. Sorry, did I just copy the file again? Sorry. I believe it's this file, right? Yeah, this is the file. So this is how that happens. Now, other than that, we need few stuff to define at this point so that it helps us for better results or better analysis, right? What those are. Now, these probes, they are excellent tools in COMSOL that what it does is you can specify some sort of variables that you want to analyze during the whole result calculation. So we need global variables, and let's say I want to analyze the temperature in this battery in second and third separately, right? So what you can do is we need to write that variable here. So where do you get those variable? That's the question here. So I'm dealing with temperature, right? So like the temperature. Now for that, since I want those in these lithium batteries, we need to define the extra modules that we need to that we will need. So let's define that right now. And we can go in electrochemistry, and we need to go here batteries, and then we need to go this lumped batteries, because that's what we're working on, right? So we need three of them, since each of the batteries will be simulated separately. One, add another, double click. That's the second battery. That will be our third battery. So now if you go like here, cell equilibrium potential, press this, and in the equation view, you can actually see what that variable that I'm looking for should be, or maybe it's not here, then maybe here. Yeah. So this LB means like lithium battery, this temperature. This is the variable that I want to study, right? Now, before you do that, make sure like for cell, this is just for like first battery, right? Like LB means first, this is what I want it to refer to only first battery. For that, you have to select this one. You get, instead of going there, remember you already defined the selections here, so select just this battery 1, and for this one select battery 2. Okay, and for this one select battery 3, right? So that's how it helps the this whole selection thing that we defined at the geometry stage. And as you can see here in the voltage losses equation view, that this is the temperature variable. This is what we want to analyze, right? So just copy this one, and notice that if we go here, the for battery 2 in the equation view, this is the exact same thing, just LB2. That's the change in this variable, right? That's because for first battery, this abbreviation LB is how you refer to this submodule, and LB2 would be how you refer to the second module. So let's just copy this one here and put it where we want this to be. That is the global variable. That's where what we want to analyze, right? So this one be for battery 1, so that let's rename it as temperature of maybe battery 1, right? But let's see. Oh, sorry, there is no, actually we don't have LB1, it's simply LB. Yeah. And also, since we want this in the form of table, maybe, so we need to create an extra new table here. So this is the table 1. As for plot window, we can just simply plus plot here, and that would give us like extra plot when we calculate the result. And similarly, let's just copy this one, maybe duplicate, and put a 2 here. That would be for battery 2, and let's name this as 2 again. Create another duplication, that would be battery 3, and the temperature for that is LB3. And remember how you get these variables. You go to this voltage losses equation, and there you can see this variable. Make sure to remember that, because this is how you find different variables in your whole simulation that you might need to like use for custom based results, like you want to do it on your own, or maybe something that the COMSOL doesn't offer you. You have to like manually find that variable.